Hi and Assalamualaikum everyone. For this video, I'm going to show you some of the solved examples that I took from final exam question as well as from the previous test. Okay, for first problem, these are taken from final exam question in 2012 and 2013. So, given the following functions here, f1, f2, and f3, you need to find the Laplace transform. And for each question, the marks given is 2 marks. Okay, for the first question here, f1 is given as exponent negative t minus theta ut. Okay, so if we see here, this is actually an exponent function. Okay, and for this one, you can further simplify it to become exponent, and here negative multiplied by negative is positive, so you can take out exponent tau. So we leave here exponent negative t ut. Okay, so exponent tau is actually constant, okay, because it does not involve t. Okay, so from here we can refer to the list of formulas for Laplace transform pairs, and then from here we can use exponent at ut, which will give you the Laplace transform pairs of 1 over s plus a. So f1s, which is the Laplace transform of f1t, is equal to exponent tau. So you just leave exponent tau like that because exponent tau is actually constant. So a here is 1. Okay, if we mesh with this, a here is 1. So this one will become 1 over s plus 1. So this is the answer for question 1. Question 2, given that f2t is equal to sine omega naught t minus tau ut minus tau. So basically this is a sine omega naught t, which is delayed by tau. Okay, so this is sine omega naught t delayed by tau. So what we can do here is we refer to the sine pairs for the Laplace transform pairs. So sine omega t ut will give you the Laplace transform pairs of omega divided by s squared plus omega squared. And another one is referred to the time shifting properties. So time shifting properties will give you f t minus t naught u t minus t naught. Okay, and the Laplace transform is fs. Okay, multiplied by exponent negative s t naught. Okay, so in this case, if we mesh here with the original equation, okay, omega here is omega naught. So omega is omega naught, and then t naught here is actually tau. Okay, t naught is actually tau. So we just have to find the Laplace transform for fs, and then we multiply by exponent negative s t naught. So from here we can solve f2s, which is the Laplace transform of f2t, which is equal to omega naught divided by s squared plus omega naught squared, and then multiply by exponent negative s tau. Okay, so this is your answer for question 2. 3, f3t is given as t power of 4 plus 5 t power of 3. So from here, we can use the superposition properties in which we find the Laplace transform for the first part here, t power of 4, and then we plus with another Laplace transform for this 5t. Okay, so from here, we can use the Laplace transform pairs of t power of n ut, okay, which give you the Laplace transform pairs of this. Okay, and then from here we can put in the equation. So f3s is equal to Laplace transform of t power of 4 plus Laplace transform of 5t power of 3. And then this will give you this answer. Put in the value here, okay, plus 5 Okay, here divide by s power of n equal to 3 here, so 3 plus 1 equal to 4. Okay, so you solve this, which is equal to 4 multiplied by 3 multiplied by 2 multiplied by 1. So this one should be 24 divided by s power of 5 plus 3 multiplied by 2, 6. 6 multiplied by 5 is 30. So this one is 30 divided by s power of 4. Cool? Okay, so these are the answers for problem number 1. So now moving on to problem 2. The Laplace transform of a signal Vt is given as t exponent negative 2t cos 2t ut. Okay, and the Laplace transform of Vt is given as Vs. Okay, obtain Rt that is corresponding to each of the following transform Rs using suitable Laplace transform property pairs. These are taken from test 2 2015 and 2016, and for each question here the marks given is 3 marks. Okay, so let us solve the question one by one. For this question you have to be a bit creative. You have to rearrange the numbers here, okay, the Laplace transform for Rs here, so that we can follow any of the properties listed in the list of table for Laplace transform properties. Okay, so we can see that we can use time scaling property, which is given as Rt equal to VAT, and this will give you Laplace transform of Rs equal to 1 over A Vs divided by A. Okay, because we can see the scaling at the in the bracket here with the S, right? So we rearrange Rs, okay, so that we can follow this form. So V2S can become S divided by 1 over 2. Okay, the problem is we want to make sure that A here, 1 over 2 here, is also at the outside of the bracket, which is the constant outside of the V here. Okay, so what we can do here is multiply by 1 over 2 divided by 1 over 2. Okay, so 1 over 2 divided by 1 over 2, which is actually 1. So V as divided by 1 over 2. Okay, so eventually this will become 1 over 2, 1 divided by 1 over 2. Okay, which A here should be 1 over 2. V as divided by 1 over 2. So now we have rearranged the equation so that it follow the form of one of the properties, which is the time scaling properties. So this is from time scaling. Okay, so from here we know that A equal to 1 over 2. So we can use our knowledge from here so that we can put 1 over 2 multiplied by t in the original Vt equation. Okay, so Rt here, which is or Rt here should be VAT. Okay, VAT. So V in this equation is given as this. Okay, so what we can put here is, because also there is another constant which is 1 over 2 here, so this one should be Rt equal to 1 over 2 V. A is 1 over 2, so 1 over 2 t. Okay, so at every t we multiply by 1 over 2 at from the original Vt. So this one should be 1 over 2 multiplied by, so the first t here we replace it with t over 2. Okay, so every single t here we replace it with t over 2 or 1 over 2 multiplied by t. This is the same. Okay, so this one t over 2 multiplied by exponent negative 2 is t over 2 cosine 2 t over 2, and this one is u. This one is still ut. Okay, because this one wants to show the unilateral Laplace transform. Okay, so from here you solve this. This one will become 1 over, sorry, this one should be t. So t over 4 exponent negative t cos t ut. Okay, so now you already answer question number 1. For question 2 here, we can also find any of the Laplace transform properties that can match with this form of RS. Okay, so from here, we can use time multiplication property. Okay, we can use using time multiplication property. So this is why you have to do lots of exercise so that you becomes familiar what property you want to use to solve the Laplace transform. Okay, so from here, time multiplication property give the Laplace transform press of Rs equal to negative 1 power of n, and then differentiation with n, the order of n, p s divided by es. Okay, so from here we can match with the equation here, so we can find out that we have found out that n is equal to 1. So RT here equal to, RT here is actually equal to t power of 1 Vt. So this one, we put the original V in this equation. So t cos 2t. Okay, so solve this. We get t squared exponent negative 2t cos 2t ut. Okay, so this is the answer for question 2. Okay, for next question, problem 3. Consider a linear time invariant. LTI stands for linear time invariant system. Okay, so by now you should know we will use the term LTI for many chapters. Consider a LTI system characterized by the differential equation given as this equation. Okay, so this is a non-homogeneous equation because it is given that xt is equal to exponent negative t ut. Okay, and the initial conditions are given as y prime o, y prime 0, or y0 is equal to 1. So again, y0 means the condition of the original equation of this equation when t is equal to 0. Okay, so we will learn more about the initial condition in the next part. Okay, and you need to use the Laplace transform technique to determine the output of yt. So this is when the knowledge of your Laplace transform is very useful. Okay, so that you can solve this differentiation equation much faster than using in Laplace domain than using in time domain. So the mark given is 10 marks, and this question is taken from finalizing question in 2013 and 2013-2014 semester 1. So for this question, you need to use the differentiation property, okay, in the Laplace transform table. Okay, so from here we Laplace everything, the whole equation we Laplace perform the Laplace transform. Okay, so when first we perform the Laplace transform for differentiation of yt with the order of 2, okay, and this one will become s squared ys minus sy0 minus y bar or y prime 0 plus 4, okay, which is the constant outside the bracket. So this one is only first order of differentiation, so it will become sys minus y prime 0. Okay, so you need to be able to perform the Laplace transform for the differentiation first. Okay, so please practice that. Okay, just look at the formula in the Laplace transform table, and also replace the order, which is n. Okay, identify the n and replace the order. And this one should plus 3ys. Okay, and then from here you also need to perform Laplace transform for this side. Okay, so this just for this side you just have to refer to the Laplace transform pairs. So this will give you 1 over s plus 1. Okay, so from here you insert the value of phi bar 0 here and y0 here, which is equal to 1. So this one, you can put the value which is 1, and this one also which is 1. Okay, and this one 1 as well. Okay, so when you put the value, okay, this will become s squared ys minus s minus 1 plus 4sys minus 1, but this one multiply by 4, so this one should be 4 minus 4 plus 3ys equal to 1 over s plus 1. Okay, so you factor out ys, okay, outside the bracket, and then whatever numbers that multiply by ys you put in one bracket. So this one is x squared plus 4s plus 3, okay, minus this one, minus 1 minus 4 become 5, so this one is minus s, so minus s plus 5, right? So we take out the negative, this one become positive, equal to 1 over s plus 1. Okay, so from here you can rearrange so that this one will become 1 over s plus 1 plus this one you put on the right hand side, so plus s plus 5, and you can actually divide this, okay, because you want to find ys. So this one you can perform the factorize, so you this one will become s plus 3 s plus 1, so it becomes right. So here you rearrange again, okay, so the s plus 1 can multiply by s plus 1 here, okay, and this one will become like this. Okay, it will become like this when you rearrange. So now you multiply and rearrange, multiply and solve for this. Okay, so that it will become here equal to, you rearrange so that you can perform the partial fraction theorem. Okay, so this one will become s squared plus 6s6 divided by s plus 1 squared s plus 3. Okay, so from here you can perform the partial fraction theorem. Now, to perform a partial fraction theorem for these equations, it will become a divided by s plus 1 plus b divided by s plus 1 squared plus c divided by s plus 3. So we multiply both sides here, left and right side, by s plus 1 squared s plus 3, so that we want to cancel out here the denominator. So this one will become s squared plus 6s plus 6 equal to a s plus 1 s plus 3 plus b s plus 3 plus c s plus 1 squared. Okay, so you rearrange, or you open up the equation. A s squared plus 4s plus 3 plus b s plus 3 plus c s squared plus 2s plus 1. Okay, so rearrange so that you can put s squared in one part, okay, of the equation, and then s in another part of the equation. So here it will become a plus c s squared plus 4a plus b plus 2c for s, okay, because this is 2s multiplied by c, and then another one is all constant, which is 3a plus 3b plus c. Okay, And from here, you try to mesh with the left hand side of the equation. So I'm teaching you now the partial fraction theorem. Okay, but there are many ways for there are other ways for partial fraction theorem that you can use as long as you can get the value of a, b, c. Okay, so for here, a plus c is equal to 1. For a plus b plus 2c is equal to 6. 3a plus 3b plus c is equal to 6. Okay, you can put in the form of matrix here. Okay, it will become 4, 1, 2, 1, 0, 1, a, b, c equal to 6, 6, 1. Okay, so from here, we can get a equal to 1.75, b equal to 0.5, c equal to negative 0.75. Okay, so how to get this? You can solve these equations. Okay, c is equal to 1 minus a. So c you put in this equation, then you will get like this. Okay, so I hope that you know how to solve this, right? Because you have learned this before in engineering mathematics. So from here we will get, okay, so I will solve here, ys equal to 1.75, which is a, divided by s plus 1, plus 0.5 divided by s plus 1 squared, plus sorry, this is negative. For c it is negative, so we put negative here. Minus 0.75 divided by s plus 3. So when you put like this, okay, when you open up the equation and then you solve part by part here, then from here it's much easier to perform the inverse Laplace transform. Okay, so yt here is equal to inverse Laplace transform of ys. Okay, so this is 1.75. I think by now we should know already if we divide something, or if at the denominator here is s plus something, this one should be exponential function. Okay, if it is not too complicated. But if there's something s here at the numerator, it might be cosine or sine function, right? So 1.75 exponent negative t ut plus 0.5 t exponent negative t ut, this one should be t, okay? And then minus 0.75 exponent negative 3 t. Okay, so now you have answered the equation, problem 3. And if you notice here, you need to show step by step on how you obtain the solution. Or you cannot just somehow give the value of ys here and then you will get this. Okay, I will not accept that. I will only accept the answers when you show step by step how you got the solution. Okay, so this one is 10 marks. For next question, problem 4, given the question taken from final exam 2012-2013, semester 2, given the Laplace transform for a signal ht as s plus 2 divided by s squared plus 4 multiplied by exponent negative s. So you need to find ht. How to find ht is by performing inverse Laplace transform of hs. For this question, 5 marks is allocated. Okay, so I'm going to solve this for you. To solve the inverse Laplace transform is to rearrange the equation so that it will become in the form of that match the property of Laplace transform or the Laplace transform pairs. Okay, so from here we can rearrange the equation. Open up the equation first. So this one will become s divided by s squared, and then for here we can change to 2 squared plus 2 divided by s squared plus 2 squared, and then this one is multiplied by exponent negative s. Okay, to solve this you can use cosine properties. Okay, sorry, cosine Laplace transform pairs, sine Laplace transform pairs, because it gives you the equation form which match the original hs here. And then we can also use the time shifting property. Okay, because time shifting property will give you Fs multiplied by exponent negative st naught, which match this Hs. Okay, so from here we can solve Ht, T, which is equal to inverse Laplace transform of s divided by s squared plus 2 squared plus inverse Laplace transform of 2 divided by s squared plus 2 squared, and then the whole of this multiplied by inverse Laplace transform of exponent negative s. Okay, and from here the inverse Laplace transform of s divided by s squared plus 2 squared is cosine. Okay, when you see s at the numerator here, you find in the Laplace transform table, okay, the answer which have s at the numerator. Okay, so from here we can get cosine 2t, because omega is 2 here, plus sine 2t ut. However, here you need to change t equal to t minus 1, because we want to follow the time shifting properties as well for this exponent negative s, and t naught here is 1. Okay, t naught here is 1. So for every t here, you put t minus 1, or you replace t with t minus 1. So cosine 2t minus 1 plus sine 2t minus 1. Okay, and then this one is u t minus 1. Okay, which is the unit step function. Okay, so this answer the question problem 4. The next problem 5. This is taken from final exam 2014-2015 semester 1. Consider a linear time invariant or LTI system as in figure Q5A1. Okay, so this is a linear time invariant system. Given the input signal st as in this figure, okay, Q5A2, and ht is given as rectangular function multiplied by ut. So basically, this is a rectangular function only at the positive side. Okay, and the output from st and ht here is given as yt, which then multiply or modulate with sine 50t to become zt. Okay, so for the question, referring to input signal at t, first you need to write its expression in terms of step unit function. So this is merely your knowledge from chapter 1. Okay, the given mark is 2 marks. And let's catch ht, which is a rectangular function just now, in time domain, and obtain its Laplace transform, hs, on also 2 marks. And by using the properties of Laplace transform, determine the mathematical expression of ys and zs. So now this one you have to refer to the diagram of LTI system. And based on your answer in part 3, what is the process that has been performed to obtain the output signal zt? So this is based on your understanding of the system. Okay, so first we answer question 1 and 2. To answer question number 1, you need to use your knowledge to write the equation for xt, okay, in terms of unit step function. So xt is given as this these triangles. Okay, so again, if you still don't know about how to obtain this equation, please study back my previous videos from chapter 1. So the time involved, okay, that has changes in the signal is 0, 2, and okay. From here you can write the unit step function that corresponds to the time. So first ut, second one is ut minus 2. Okay, remember, if this is positive, this one should be negative. Okay, this bracket, so this one is ut minus 3. Okay, so the whole equation is at t. Okay, so we fill the bottom row first. Before 0, xt is 0. Between 0 to 2, xt is 2. Between 2 and 3, xt is 1. And after 3, xt is 0. Okay, so from here we fill the table here. So before 0 is 0, and then you put 2, which is same as this, and then all the columns you put 2, and then this one should be 0 0, and this one should be a number that when you minus 2 with this number, it will become 1. So it is obvious this one is -1. Okay, another one, 0 0 0. So 2 minus 1 is 1. So you should add another number to become 0. So this one should be -1. So from here we can get xt, which is equal to 2 ut minus u t minus 2 minus u t minus 3. Okay, so this is your answer. So this one should be t, sorry. Okay, so now you can get 2 marks just by using your knowledge from chapter 1. For question 2, you have to sketch HT in time domain and obtain its Laplace transform HS. And HT here is given as rectangle T ut. So now you need to know the original form of rectangle function. Okay, so rectangle function has signal which is equal to 1 from -1/2 to 1/2. This is the original rectangle T function. Okay, so this one is something that you have to remember. Okay, multiply by ut. So ut is given like this, okay, which is 1 after t is bigger than 0. So from here you know that when you multiply this with ut, only positive side of the rectangle function will remain. Okay, and the negative side here will become 0 because you multiply with 0. So this one will become ht like this. Okay, so you basically answer part of the question here, ht in time domain. So this is 1, the time here is 1/2. Answer question 2, you need to find HS, which is the Laplace transform of HT. So if we see from the Laplace transform pairs, there is no Laplace transform pairs or answer for rectangle. Okay, unlike the Fourier transform where you can find the rectangle function. So now you need to find HT in terms of unit step function. But by now, if you have done lots of exercises, you will know that this is actually summation or the superposition of unit step function. So basically, HT is equal to ut minus ut minus 1/2. Okay, this is actually HT is actually ut minus ut 1/2. Okay, so when you see any rectangle, okay, you should be able to derive the equation of the rectangle in terms of unit step function. You can use this table first if you are still not familiar, but once you are familiar, you can derive this straight away. Okay, this one should be ut minus ut minus 1/2. Okay, so from here we can find the HS, okay, which is the Laplace transform of HT. So you Laplace transform the whole equation here, you will get so this one Laplace transform of ut, and also minus Laplace transform of ut minus 1/2. Okay, so from here you can get 1/s minus exponent negative 0.5s because this have a time shifting properties, divide by s. Okay, so now you answer question 2 and you can get 2 marks for this. For question 3, by using the properties of Laplace transform, determine the mathematical expression of ys and also zs. So we need to refer back to the system here. Given that yt is convolution between xt and ht in time domain, so in order to find ys, we need to perform the multiplication in Laplace domain. So you have to find xs first, and then hs we have already know from question 2, and then we multiply together xs and hs to obtain ys. Okay, so from here we know that for question number 3, yt is actually a convolution of xt with ht, okay, which is the impulse response of xt. So we can find ys, which is xs multiplied by hs. So xs here, we have found the equation of xt in terms of unit step function. So we can perform the Laplace transform of xt easily here using the Laplace transform pairs and also Laplace transform properties. Okay, so this one should be Laplace of 2ut minus Laplace of ut minus 2. So now we can use time shifting properties for this, minus Laplace of ut minus 3. So from here, we can get 2 over s minus exponent negative 2s divided by s, okay, because we have a time shifting properties. Okay, so now you need to be able to use both properties and also pairs at the same time, right? And then minus exponent negative 3s divided by s. Okay, from there we can find ys, which is ss multiplied by hs. Okay, so this one will become 2 divided by s minus exponent negative 2s divided minus exponent negative 3s divided by s multiplied by hs, which is given as 1 divided by, minus exponent negative 0.5s divided by s. Okay, so multiply this together. Okay, you will get 2 minus 2 exponent negative 0.5 s, okay, minus exponent negative 2s. Okay, you open up the equation, plus exponent negative 2.5s minus exponent negative 3s plus exponent negative 3.5s. Okay, divide by s squared. So remember, when you multiply the exponent function together, the power of the exponent you need to add or minus depending on the polarity here. Okay, so this is the equation for ys. Okay, this is the equation for ys. For zs, okay, because you need to find zs as well. So if you refer back to the system here, zt is equal to yt, which multiply by sine 50t. So basically, when you do this, you need to refer to modulation properties, okay, because you multiply time domain function with sine function, okay, sine omega t function. Okay, this is the properties taken from the table for modulation for sine. So we can use this because zt is equal to yt multiplied by sine 50. Okay, so in this case, yt here is ft here, and omega here is 50. Okay, so we can use the equation here because yt, the Laplace transform of yt, which is ys, we have obtained it before. So zs is equal to j over 2 ys plus j50. Okay, plus j50 because omega naught is equal to 50 minus ys minus j50. Okay, so this is zs. So we use back ys that we obtain here. This will be very long equation. Okay, because every single s here we replace with s plus j50. So it will be very long equation. Okay, so this one will become j divided by 2. Okay, so login 2 minus 2 exponent negative 0.5. And then for the first s here, we replace with s plus j50. Minus exponent negative 2, okay, which is this. We replace with plus j50, and then plus exponent negative 2.5, we replace with s plus j50, okay, minus exponent negative 3 s plus j50, and finally plus exponent negative 3.5 s plus j50. Okay, so it will be a bit messy here because of the space. So divide by s plus j50 squared. So this is only one part of the equation, which is s plus j50. Okay, we haven't done this part yet. Okay, right, for this part you need to replace s minus j50 at every single s here. Okay, so we minus j over 2 because multiply by this part. Okay, so I already written the full equation here. So every single s here you replace with s minus j50. Okay, including at the denominator. Okay, so this one should be minus. Okay, so this is the answer for question 3. Okay, you have to read the question properly, because this question only asks you to determine the mathematical expression of ys and also zs. So that is why the mark given is only 4 marks, okay, which normally 2 marks for ys and 2 marks for zs. And the question doesn't ask you to perform the inverse Laplace transform of ys in order to obtain yt, and also zs in order to obtain zt. Okay, so now do not waste your time to perform the inverse Laplace transform. So again, read the question properly. So this is only for ys and zs. Okay, so number 4, this is based on your understanding for the process. So based on your answer here, what is the process that has been performed to obtain output signal zt? So obviously this is the modulation process. You can just answer modulation or frequency shifting. Okay, frequency shifting by omega naught equal to 50 radian per second. Okay, so this is the answer for question 4. Okay, for problem 6, this question is taken from one of the textbook. Okay, find the inverse Laplace transform of xs, which is given as s plus 3 plus 5 plus exponent negative 2s plus divide by s plus 1, s plus 2. Okay, so from here, we can open up the equation so that it will be in the form that we can perform the inverse Laplace transform, or we can perform the partial fraction theorem. Okay, so xs is s plus 3 divided by s plus 1, s plus 2. Okay, so that we can put this as one part, and then another one is plus 5 exponent negative 2s divided by s plus 1, s plus 2. Okay, so this is basically we rename it as 1s plus s2s, and if you notice here we have exponent negative 2s. It means that this one is actually time shifting properties, in which when you perform Laplace transform of time shifting properties, it will give you exponential function. Okay, so exponent negative 2s. Okay, so we solve for x1s first. x1s is given as s plus 3 divided by s plus 1, s plus 2, which is a divided by s plus 1 plus b divided by s plus 2. Okay, so again, using the partial fraction theorem knowledge of yours, we can get a. So a is equal to s plus 3 divided by s plus 1 multiplied by s plus 2, and then multiply the whole equation by s plus 1. So this one should be when s equal to negative 1. Okay, so we put s equal to negative 1 so that at the denominator here will become 0. Okay, the denominator under a here. Okay, so you can cancel out this. So put s equal to negative 1 in a here so that we can get here 3 minus 1 is 2. Okay, this one. So for b, using the partial fraction theorem again, this one is equal to s plus 3, s plus 1 s plus 2 multiplied by s plus 2 for s equal to negative 2. Okay, so put in the value of s equal to negative 2, we'll get s equal to negative 1. So from here we can get x1 equal to a, which is 2 divided by s plus 1 plus sorry, this one should be negative 1, so minus negative 1. Okay, this minus by negative 1 divided by s plus 2. Okay, so this is more to the form that we can perform the inverse Laplace transform. So now we settle for x to s. So again, x to s, we solve to perform the partial fraction theorem. Okay, so that we can separate s plus 1 and s plus 2 here to become two parts of equation. Sorry. A divided by s plus 1 plus b divided by s plus 2. Okay, so I'm not going to show you the partial fraction theorem again. So from here, I get a equal to 5, b equal to negative 5. So x to s is equal to 5 divided by s plus 1 minus 5 divided by s plus 1. Sorry, this one is s plus 2. So from here, we can obtain xs equal to s1s plus x2s. Okay, and x2s here, remember you have to multiply by exponent negative 2s. Okay, to obtain xt, you perform an inverse Laplace transform for each individual x1 and x2. So for this one, inverse Laplace transform of 2 divided by s plus 1 minus 1 divided by s plus 2. So of course this one is exponent function. Okay, and plus inverse Laplace transform of 5 divided by s plus 1 minus 5 divided by s plus 2, and this one have to multiply by exponent negative 2s. Okay, so this one is actually time shifting properties. Okay, so from here, this one is 2 exponent negative t minus 2 exponent negative 2t ut, and for x2, because there is a time shifting properties here, so this one should be 5 exponent negative t minus 2 minus 5 exponent negative 2t minus 2 yt minus 2, because if we perform the inverse Laplace transform for 5 divided by s plus 1, it should be 5 exponent negative t. But because of the time shifting, this is at the t naught here is actually s, so you need to refer back to the time shifting properties. So every single t here we replace with t minus 2. This one like this, then multiply by u t minus 2. Okay, so now you answer problem 6. Okay, for final question, problem 7. Find the inverse Laplace transform of xs, which is given as this equation. Okay, so if we see this equation, the order of the numerator is higher than the order of the highest order at the denominator. Okay, because this is s power of 3 and this one is s squared. Again, to solve this, you use your knowledge in engineering mathematics, so we can use long division. Okay, how to use long division? We divide this one. 2 s power of 3 minus 9 s squared plus 4s plus 10. Divide by s squared minus 3 s minus 4. Okay, so you divide first this part, 2s, when you multiply by the whole equation here, this one should be 10. Okay, become 2s power of 3 and 2s multiplied by 2s here multiplied by 3s here should become negative 6s squared and then 2s multiplied by 4 will become negative 8s. So you minus this. Okay, so this one will become 0. And then 9 minus 6 here will become negative 9. Negative 9 here, when minus 6 here will become negative 3s square, and then 4 minus 8 here will become 12s. Okay, so this one we bring it down here, plus 10. Okay, and then multiply again. So this time, because when we want to multiply, we make sure that we multiply so that we can cancel out the first part of the equation. So this one multiply 3. Okay, so here we will get negative squared, okay, plus 9s plus 12. Okay, so you minus this. Simply you cancel out this. 12 minus 9 equal to 3s. 10 minus 12 become 2. Okay, so basically your equation will become 2s minus 3 plus, okay, 2s minus 3 is the one that we have factorized, plus 3s minus 2, which is the balance here, divided by s squared minus 3s minus 4. Okay, so from here you can further simplify it to become 2s minus 3 plus 3s minus 2 divided by, you can factorize this, s plus 1, s minus 4. Okay, so from here we know that we can use the partial fraction theorem for this part. Okay, so 3s minus 2 divided by s plus 1, s minus 4, sorry, minus 4, this is minus 4, will become a divided by s plus 1 plus b divided by, sorry, this is b divided by s minus 4. Minus 4. Okay, you use the partial fraction theorem. Again, I'm not going to show the step because I've shown in previous slide. So we can obtain a equal to 1, b equal to 2. So the whole equation SS will become 2s minus 3 plus 1 divided by s plus 1, which is a, plus b is equal to 2, so 2 divided by s minus 4. Okay, so this is more towards the form that we can perform inverse Laplace transform. Okay, so xt here is equal to inverse Laplace transform of SS. Okay, so you perform the inverse Laplace transform for each of these individual equation here. So inverse Laplace transform of 2s minus inverse Laplace transform of this is 3, sorry, 3 plus inverse Laplace transform of 1 divided by s plus 1 plus inverse Laplace transform of 2 divided by s minus 4. Okay. Okay, so first, to perform the inverse Laplace transform of 2s, if you refer to the table, you cannot find exactly 2s, okay? But what you can find here, you can also refer to the properties of Laplace transform, and you find out that if we use differentiation, we can get the Laplace transform in terms of s. So if the differentiation is, the order of the differentiation is n equal to 1, we can get fs for the equation. And fs in this case is 1, okay, because of these two. Okay, in this case fs is 1, however for this equation it is 2, so we can also refer to delta t. Okay, the transform pairs of delta t. Okay, if we refer back to the table, you can see that delta t will give you Laplace transform of 1, and also for the differentiation properties, dft dt will give you the Laplace transform of, for n power of 1, this is sfs. Okay, so from here we know that we can use the delta function, okay, to as the Laplace transform pairs for 2s. So it will become here equal to 2 differentiation of delta t divided by dt. So that's why I have told you before that in order to perform the inverse Laplace transform, you have to be creative. Okay, so 3 here, we can use delta t straight away. Delta t pairs, the minus 3 delta t, and this one plus exponent negative t ut, and this one plus 2 exponent negative 4t ut. Okay, so now you have answered problem 7. Okay, so that is all. That's all for this tutorial. Again, if you have any question, please WhatsApp me directly. Also, you can also refer to the past year test question for test 2 if you want to find further question on Laplace transform, and you can also refer to past year final exam question, which all of that I have uploaded on the e-learning. Okay, so thank you very much.